So now that we know how that works, the next part of the story is as follows. And we're not going to have time to completely do this justice today, but just to get us started so that when we come back next time, we can pick up where we left off. What I'd like to be able to do now is the analog to what we were able to do before, and that was on this page, is we wanted to somehow go backwards, right? We wanted to undistribute from a sum of two things into a product of a greatest common factor with some stuff that remains on the inside, right? Once we've identified what the greatest common factor is, that should give us a road forward to factor that greatest common factor out. So that's what we need to do next. And just to get us thinking in that direction, let's go back to one of the examples that was just on the screen. So let's say I pick on, why don't we do part H? So here my expression is 9y to the fourth plus 3xy to the fourth. If we're doing what we did on the previous slide, then once we know what the greatest common factor is, and we decided here that the greatest common factor was 3y to the fourth, we should be able to use that greatest common factor to undistribute in this expression. Now is when it matters whether we had a plus or minus in the middle, because chances are we're going to have the same sign also in the middle of these parentheses. So we started with addition, let's continue with addition here. So now we just need to do the undistributing process. If I were to distribute this expression, then I should go backwards to what I started with originally, which was 9y to the fourth plus 3xy to the fourth. So what are some ideas, and we're going to pick up on these on Wednesday, for how I would figure out these two blanks? What should I put in the left-hand blank here? 3y to the fourth times this has to give me 9y to the fourth. How do I figure out what belongs there? Okay, it's 3. And why is it 3? Okay, so you're observing that in order to get the coefficient of 9, we would need 3 times 3. And why is it only 3? Why don't we also need other stuff here? Max? Yeah. This y to the fourth that we need on the outside here is already taken care of by the y to the fourth that's in the front of these parentheses, and so we don't need anything additional for this 3. What about the second term over here? It's x, and why is it just x? Yeah, exactly. It's the only thing that we need that isn't already taken care of in this 3y to the fourth, right? So what people will often do is just do that backwards thinking. What do I need and what am I missing, right? And what do I already have out in the front? Compared to 3xy to the fourth, what 3y to the fourth is lacking is an x. Compared to 9y to the fourth, what 3y to the fourth is lacking is a 3. So doing that backwards thinking is one way of figuring out what these cofactors are. Another way is something we'll talk about next time, which is to divide. To divide each of these terms by the greatest common factor. Use the properties of exponents, and you'll figure out what these cofactors are as well. So that's where we're going to go next with all this. And